Hi students, this is Nagendra Babu. In my previous video, I taught about bar graphs, histograms, frequency polygons and frequency curves. Now, let us learn how to represent the cumulative frequency curve. First of all, we have to learn how to prepare the distribution table, cumulative frequency distribution table. Let us see the example. These are the class intervals given 0 to 10, 10 to 20 and so on up to 9 to 90 to 100 given. And these are the frequencies 5, 3, 4, 3, 3, 4, 7, 9, 7, 8. All these are corresponding frequencies of these class intervals. First of all, we have to find another column, that is cumulative frequencies. Cumulative frequencies means take another column that is represented by CF. CF means cumulative frequencies. First of all, write the first frequency as it is, that is 5. Next, to this 5 add the next frequency and write here, that means 5 plus 3 gives 8. And to this 8 add the next frequency and write here, so 8 plus 4, that is equal to 12. And to this 12 add next frequency, 12 plus 3 equal to 15. And to this 15 add 3, that is equal to 18. For this 18 add 4, 18 plus 4 is equal to 22. To this 22 add 7, that is equal to 29. 29 plus 9 equal to 38. 38 plus 7, this is equal to 45. 45 plus 8, this is equal to 53. These are called cumulative frequencies. So, cumulative frequencies means first frequency write as it is. So, to this frequency add the next frequency and write here, that is 5 plus 3 is equal to 8. Like that all these frequencies are added. Make sure that class intervals must be continuous or exclusive. That means these are the limits as well as boundaries also, because in the first class 10 is the upper boundary and the next class lower boundary is 10. If these two are equal, then we can take all these as boundaries also. So, these are boundaries. The left side values are called as lower boundaries and the right side values are called as upper boundaries. And these are cumulative frequencies. There are two types of curves of this related to cumulative frequencies. They are called as ogive curves. Ogive. They are called as ogive curves. Ogive curves. Ogive curves means less than cumulative frequency curve and greater than cumulative frequency curve. Both are together called as ogive curves. So, first let us learn how to draw the first ogive curve, that means less than cumulative frequency curve. For that we need, for less than cumulative frequencies, we have to take upper boundaries and cumulative frequencies. Let us see how to take those columns. Students, to draw the less than cumulative frequency curve, we need additional two columns. That is, first one is upper boundaries. We have to take upper boundaries in one column, and in the next column less than cumulative frequencies. First of all, I am making the table for less than cumulative frequency curve. That means for less than cumulative frequency curve, we need upper boundaries and less than cumulative frequencies. Upper boundaries. To get the upper boundaries, make sure that classes must be continuous. Continuous means this upper boundary and its lower boundary should be same in every class, in every succeeding classes. That means this in this class the upper boundary is 10 and in the next class lower boundary is 10. So, these two are equal, like that 20 equal to 20, 30 equal to 30, 40 equal to 40. Like that we have to ensure to be like this, that is continuous classes. Or exclusive classes. And upper boundaries means these right side values are upper boundaries. Take these boundaries in this column. That means we are preparing the table to draw the less than cumulative frequency curve. Listen carefully. For less than cumulative frequency curve, we need upper boundaries and less than cumulative frequencies. So, upper boundaries means take these boundaries 10, 20, upper boundaries, right side boundaries are taken as upper boundaries 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. These are upper boundaries. And less than cumulative frequencies. Less than cumulative frequencies means these frequencies, first of all, take this first frequency 5. And to this frequency add the next one and write here 5 plus 3 is 8, and this sum, and to this sum add the next frequency 8 plus 4 equal to 12. Like that, add all the frequencies and write, then you will get less than cumulative frequencies. That means 12 plus 3 is equal to 15, 15 plus 3 equal to 18, 18 plus 4 equal to 22, 22 plus 7 is equal to 29, 29 plus 9 equal to 38, 38 plus 7 equal to 45, 45 plus 8 is equal to 53. These are less than cumulative frequencies. Now, if we want to prepare the greater than cumulative frequency distribution, this is less than cumulative frequency distribution. If you want to prepare greater than cumulative frequency distribution, we need lower boundaries. The two columns are lower boundaries and greater than cumulative frequencies. Lower greater than cumulative frequencies means to get the less than cumulative frequencies, we added all the frequencies from the top. Here upper boundaries, and these frequencies are added from upper, that means from the top. Take upper boundaries and add from the top. For the greater than cumulative frequency distribution, take lower boundaries and add all these frequencies from the bottom. For less than cumulative frequency distribution, upper boundaries and add the frequencies from upper. For greater than cumulative frequency distribution, take lower boundaries and then add these frequencies from lower. Okay, remember it carefully, don't get confused. So, these two columns are taken to construct the less than cumulative frequency curve. That means upper boundaries are taken on x-axis, that is on horizontal axis, and less than cumulative frequencies, this column is taken on y-axis, that is on vertical axis. To construct that curve, less than cumulative frequency curve, upper boundaries, see here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. According to these values, you have to select the scale on x-axis. So, 10 difference is there between all these boundaries. That's why start from 0. Let it be 0, and the first unit is taken as 10, and the second unit is taken as 20, third unit is 30, fourth unit is 40, fifth unit 50, and the sixth unit 60, like that, seventh unit 70, 80, 90, 100. So, according to these values, we have taken the scale like this, 10 difference for every unit. And see these values 5, 8, 12, 15, 18, 22, 29, 38, 45, 53, all these are less than cumulative frequencies. So, these frequencies we must take on y-axis. The highest value is 53. That's why according to this, select the scale on y-axis. Highest value is 53. So, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units are there in this graph. But in your graph sheet, so many 32 or 33 columns or rows will be there. According to that, you can choose the scale. Now on this board, I have only 1, 2, 3, 4, 5, 6, 7, 8, 9 units are there. So according to these units, we will select the scale, we will choose the scale. So highest is 53. That's why I am taking for every unit 10 units. For every unit 10. That means this is 10, 20, 30, 40, 50, 60, 70, 80, 90 and so on. So this is selecting the scale on x-axis and y-axis. So these are upper boundaries and these are less than cumulative frequencies, LCFs, and these are less than cumulative frequencies. First of all, take this point 10, 5. 10 is taken on x-axis and 5 is taken on y-axis. That means 10 is here on x-axis and 5 means between 0 and 10. So its perpendicular distance, the meeting point of, the intersecting point of its perpendicular distance and its perpendicular distance. From 10, draw the perpendicular distance, and from 5, the 5 is between 0 and 10. From 5, draw the take the perpendicular distance. So these two will meet at this point. So this is taken as 10, 5. This is the point of 10, 5. And then 20, 8. 20, 8 means this is 20. 8 means between 0 and 10. 0 and 10 means already here we got a point with 5. 10, 8 means above this point for at another 3 lines distance on the graph sheet. So we will get a point like this here. This is 20 and 8. From here the perpendicular distance, from 8 the perpendicular distance. So these two distances will meet at this point. So this is the point of intersection of 20 and 8. And then 30 and 12. So this is 30. From here the perpendicular distance and 12. 12 means between 10 and 20 there will be 10 lines. So 10 means after 2 lines we will get 12. So from 12 the perpendicular distance and 30 perpendicular distance. So they will meet at this point. You will get accurate points on your graph sheet while you are drawing on the graph sheet, graph book. That is, so 30 and 12, the meeting point of 30 and 12 you will get like this. And then 40 and 15. So perpendicular distance from 40 and from 15. 15 means between 10 and 20. So the perpendicular distance from here you will get a point like this. From 40 perpendicular distance and from 15 the perpendicular distance, these two will meet at this point. And then 50 and 18. 50 is here on x-axis and 18 means between 10 and 20 at from below this 20 at two lines below of this 20. That means we will get a point of intersection like this. So the perpendicular distance from 50 and the perpendicular distance from 18, they will meet at this point. And then 60 to 22. 60, this is 60 on x-axis and 22 means above 2 lines of 20. So from here the perpendicular distance and from 60 the perpendicular distance like this. And then 70, 29. 70 on x-axis is this and 29 just one line below this 30. That is, you will get the point of intersection like this here. The perpendicular distance from 70 and the perpendicular distance from 29. So you will get the point like this. And then 80 and 38. 80 is this and 38. 38 means just below 2 lines of 40. 38 means 30 above 8 lines and just below 2 lines of 40. That means from here the perpendicular distance and from 80. So you will get the meeting point of those two perpendicular distances like this. And then 90, 45. 90 is here and 45 means between 40 and 50. So from here the perpendicular distance, and from 90 you will get a point like this. And then 100 and 53. This is 100 and 53 means just above the 53 lines. That means from here you will get a point of intersection like this. So I plotted all these points. Those points are 10, 5, 20, 8, 30, 12, 40, 15, 50, 18, and then 60, 22, 70, 29, and then 80, 38, 90, 45, and at last 100, 53. So these are the points I plotted on this graph. So if we draw all these points with a free hand smooth curves, we will get the curve like this. So with a free hand, don't use any scale, with a free hand join all these points like this. This is the curve we got by joining all these points with free hand. This curve is called as less than cumulative frequency curve. To construct this less than cumulative frequency curve, we selected the scales on x-axis and y-axis. X-axis upper boundary and on y-axis less than cumulative frequencies. You have to write that scale whatever you have taken on the right side of your paper. So on x-axis 1 unit is equal to 10 taken, and on y-axis 1 centimeter, that is 1 centimeter equal to 10 units. This is 1 centimeter distance in your paper, graph paper. So 1 centimeter equal to 10, and here also 1 centimeter equal to 10 units. So these are taken. You have to write that whatever you have taken as a scale. There will be 1 mark for that scale. And this is the curve I drawn. This is called as less than cumulative frequency curve. To construct this less than cumulative frequency curve, we used upper boundaries and less than cumulative frequencies. Once again, I am reminding you. So upper boundaries means in the classes the right side values are taken as upper boundaries, and less than cumulative frequencies means when you taken upper boundaries, add these frequencies from upper. From upper means from the top one is 5, and then add to this the next frequency and write like this. So these are cumulative frequencies, and also these are called as less than cumulative frequencies. So to construct this less than cumulative frequency curve, we need upper boundaries and less than cumulative frequencies. So I plotted all these points and joined all these points with a smooth curve using free hand, not used any scale. So this is called as less than cumulative frequency curve or less than OZ curve. Less than OZ. This is also called as less than OZ or lower than OZ. Now let us draw the greater than cumulative frequency curve. For that, for the greater than cumulative frequency curve, we need lower boundaries and greater than cumulative frequencies. Lower boundaries and greater than cumulative frequencies. So let us draw that one. Okay students, first let us prepare the frequency distribution table for greater than OZ curve. So we are going to prepare greater than cumulative frequency distribution table. For that, we need lower boundaries. First of all, we need lower boundaries. Lower boundaries means in these classes, the left side values are called as lower boundaries. So take these boundaries 0, 10. First one is 0, 10, 20, 30, 40 and so on. So 0, 10, 20, 30, 40, 50, 60, 70, 80 and 90. These are lower boundaries. So for greater than cumulative frequency curve, to construct or to draw the greater than cumulative frequency curve, we need lower boundaries and greater than cumulative frequencies. This column we denote as greater than cumulative frequencies. To get the greater than cumulative frequencies, take lower boundaries and add these frequencies from the lower. Take lower boundaries and add these frequencies from the lower. These are called as greater than cumulative frequencies. Add frequencies from the lower, then you will get greater than cumulative frequencies. If you add frequencies from the upper, those cumulative frequencies are called as less than cumulative frequencies. So here we are going to draw greater than cumulative frequency curve. For that, lower boundaries and add the frequencies from the lower. That means take the first frequency from the lower, that is 8. This is 8. To this 8 add the next frequency, that is 8 plus 7, that is 15. To this 15 add the next frequency. So 15 plus 9 is 24. 24 plus 7 is 31. 31 plus 4 is 35. 35 plus 3 is 38. 38 plus 3 is 41. 41 plus 4, 45. 45 plus 3, 48. 48 plus 5, 53. So these are called as greater than cumulative frequencies. Lower boundaries and greater than cumulative frequencies. Lower boundaries are taken on x-axis, that is on horizontal axis, and greater than cumulative frequencies are taken on y-axis, that is vertical axis. So these are called lower boundaries, and this vertical axis. On this vertical axis we take greater than cumulative frequencies. So write greater than cumulative frequencies. Now the first point to be plotted is 0, 53. 0, 53. So the point of intersection of 0 and 53, 0 on this x-axis and 53 on y-axis. The point of intersection of 0 and 53 is taken as the first point. So this is 0 and 53 on y-axis, that is between 50 and 60. 50 and 60, just above the 53 lines, near after 3 lines, that is 53. Between 50 and 60 there will be 10 lines in your graph sheet. So just above the 50, after 3 lines you take 53. So to that 53 and from 0, the point of intersection of these these two lines, these two perpendicular distances, you will get at 53. So that will be on this y-axis. 0 and 53 on y-axis. So that point of intersection will be on this y-axis at 53. So that is the first point, that is 0 comma 53. Next point 10 comma 48. 10 and 48. So 10 is on x-axis, that is here, and 48. 48 is after 40 or just below the 50 after 2 lines, that means 48. So there will be 10 lines, that means you have to take at after 8th line you will take 48. So the point of intersection of 10 and the point of intersection of the perpendicular distances from 10 and 48 will be the second point. So this is 10 and 48 is here. So the perpendicular distances of these two values will be this point. This is the second point. And then 20, 45. So we have to plot the point 20 and 45. So 20 is here and 45 means between 40 and 50. So exactly in the middle of 40 and 50. So the perpendicular distances from 30, that is 20 and 45. So from here 20 and between 45 means 40, between 40 and 50. So the perpendicular distances from these 2 points we will get here. So this is the point of intersection of 20 and 45. And then 30 and 41. This is 30 and 41 means above, just above the 40, that is 41. So 30 and 41. The point of intersection of the perpendicular distances of these two values 30 and 41, you will get here this point of intersection. And then 40, 38, this is 40, 38 means after 30 at 8th line, that is you will get those two perpendicular distances, their point, the point of intersection of those two values will be here. And then 50 and 35, this is 50 and 35, between 30 and 40, so we will get this point here. This is the point of intersection of 50 and 35. Then 60 and 31, so you will write all these here, 20, 45, next one is 30, 41, and the next value is 40, 38, already we plotted this, and then 50, 35, 50, 35, and then we are going to plot 60 and 31. 60, 31, the point of intersection of 60 and 31, 60 is here and 31 is here, just above 30. So that is 60 and 31 you will get here. This is the point of intersection of 60 and 31. And then 70 to 24, this is 70 and 24 means above this 24th line. So we will get its point of intersection like this here. That is 70 and 24. Next point is 80, 15. This is 80, 15. So point of intersection of the perpendicular distances of 80 and 15. So this is 80 and 15 means between 10 and 25, exactly the middle value of 10 and 25, you will get this point here. So 80 and 15. And then 90 and 8, the last but not the least point is 98. So this is 90 and 8 means just below the 10 after two lines, that is 8. So 90 and 8, the point of intersection of these two perpendicular distance will get here. You will get like this here. So already I plotted all these points according to these points. We got these points as this column is lower boundaries and these are greater than cumulative frequencies. Be careful while you are writing these frequencies. For greater than cumulative frequency curve, we need lower boundaries and add all these frequencies from the lower. Take lower boundaries and add from the lower. Simple. So these are the points we have to plot. So I plotted all those points and join those points with a free hand. With a free hand, don't use any scale, and join all these points. This is the frequency curve, greater than cumulative frequency curve. So these two are, so already before this I drawn less than cumulative frequency curve and this is greater than cumulative frequency curve. So remember how to prepare the frequency distribution table for greater than cumulative frequency curve and less than cumulative frequency curve. According to that, plot the points and draw the curves. So these are the OZ curves. These two curves are called as OZ curves. So students, I think you all have understood this concept of constructing less than cumulative frequency curves and greater than cumulative frequency curves, which we call together as OZ curves. So I think you are understanding my classes easily. If you like my videos, share it to all your friends and don't forget to subscribe my channel. Don't forget to hit the bell icon. Thank you all very much. And tomorrow and in my next video, I will explain the concept of finding median using these OZ curves. Using OZ curves, I will explain to find the median, that is the second measure of central tendency. Thank you all very much.